So before we get started with some practice problems, I want to go over some unit conversions. Unit conversions are important because for scientists all around the world, we use the SI units, which is the International System of Units, when we compare data and information with each other. So the main ones that you'll see for units when working on the MESA machine will be the following most common ones, which is 100 centimeters, which is cm, is equal to 1 meter, which is labeled as m. The next one is 1000 millimeters is equal to 1 meter. And the next one is 1000 grams, which is represented as g, is equal to 1 kilogram, represented as kg. Now, for us living in America, we also have been exposed to and use the American Standard System of Units, and those units can be used. However, please bear in mind that since scientists use the SI units, it is in everyone's best interest to convert it to the units that scientists all around the world use. So the conversion units for American units, in the event that you choose to use American units, and the most common ones that you'll probably need to convert will be 1 inch is equal to 2.54 centimeters, 1 foot is equal to 0.305 meters, and 1 pound is equal to 0.454 kilograms. And in the following questions, we'll be doing some general conversions of centimeters and meters, etc., etc. Alright, so let's get this started. First one, potential energy problem. A marble with a mass of 125 grams is placed 60 centimeters above the ground. Calculate the marble's potential energy. Now, once again, potential energy is equal to m times g times h, where m is represented as mass in kg. The g is represented as acceleration due to gravity, which is a constant, which is 9.8 meters per second squared. And we have h, which is equal to height, and height is represented as meters. Now, please be aware in this formula, the letter m, the variable m, will be represented as a unit of kilograms, which is going to be kg, and then the variable h here will be represented as units of m, which is in meters, which is the distance. So please be aware that there's a difference between m the variable and m the unit. Now, using this formula, we would need to do some conversions before we officially get started. So 125 grams is equal to 0.125 kilograms. 60 centimeters is equal to 0.6 meters. And if we are to plug that into the formula, you would get 0.125 kilograms multiplied by the constant of 9.8 meters per second squared, multiplied by 0.6 meters, and your answer would be 0.735 kilograms times meters squared over seconds squared. Now, if you happen to use the American Standard units and you need some help converting, I would recommend you to just do a Google search. You can do like whatever the value of the thing that you're converting is. Say you want to convert, let's say 7 pounds to kilograms. If you type in 7 lb to kg, Google search will show up a calculator that will actually do the conversions for you. Alright, moving on to the next one. So the next one we're going to do is a rate problem. The wind-propelled vehicle of 450 grams traveled 125 centimeters in 7.8 seconds. Calculate the vehicle's rate of travel. Now, rate is equal to d over t, where d is represented as distance and t is represented as time. Now, for middle schoolers, just to make sure you're clear, most middle school science teachers tend to represent r as letter s and call it speed. So if you're more familiar with the term speed, you can just use the word speed and change the letter r to s if that makes you more comfortable. So in this instance, we just need to convert the centimeters to meters. So 125 centimeters is equal to 1.25 meters. Seconds is already in the right unit, so that's fine. 1.25 meters divided by 7.8 seconds. Now, please be aware in this example here, 450 grams is just a value that's actually not needed. So it's kind of unnecessary in this problem, so you don't need to use that value there in this question. If you do that, 1.25 meters over 7.8 seconds, you'll get that the rate or the speed of the vehicle is 0.16 meters per second. Now, before we move on to a kinetic energy problem, I need to make sure you are aware of the difference between rate and velocity, because the formulas look the same, but there's a very fine nuance that I need to make sure that people are aware of. So, rate or speed is equal to distance over time. The calculation for velocity also looks very similar. It looks like d over t, also looks like d over time, but it's actually displacement over time. Now, the difference between distance and displacements is that distance is how much ground the object has covered, whereas the displacement is the overall change in position from where the thing started to where the thing ended. Now, in several instances, distance and displacement can be exactly the same, and in some cases, it might not. So I'm just going to give a quick example of two instances, one for and one without. Let's say that you are at Valley Business Technology Center, and then you just did a straight shot to go to the dorms. So let's hypothetically say it's 100 meters. It's not even close. I'm just giving a random number. So if the person were to walk straight from Valley Business Technology all the way to the dining hall or all the way to the dorms, you'll notice that the distance is 100 meters and the displacement, the place where the person went from start to finish, is also 100 meters. So that's pretty much the same thing there. Now, we have a slight variation. Let's say in this instance, the person, before the person decides to go back to the dorms, the person decides to travel 125 meters to go eat food at one of the restaurants or one of the mini restaurants in that plaza. So let's just say that the person walked 125 meters. Then from that restaurant, the individual decides to walk all the way back to the dorms, which takes another 175 meters. So in this instance, the amount of distance the person traveled would effectively be 125 meters plus 175 meters, because that's the total amount of distance that the person actually walked. So that would be 300 meters. Okay. However, if you consider the displacement of where the person started to where the person ended, the amount of displacement that has occurred is effectively 100 meters. So in this instance, the two values would be different. So I hope that helps. Hope that clarifies just the little nuance between when we use the word distance versus when we use the word displacement to describe speed versus velocity. And now going to the kinetic energy problem. So we're using that same question actually. The wind-propelled vehicle of 450 grams traveled 125 centimeters in 7.8 seconds. Now we're calculating the vehicle's kinetic energy. Now, kinetic energy is equal to 1/2 multiplied by the mass multiplied by the velocity squared. Once again, mass needs to be in kilograms, which is kg. And v is represented as velocity, which is going to be meters per second. So using that formula, we would have to make sure that you first converted 450 grams to kilograms. So you have to divide that by 1,000, which would get you 0.450 kilograms. You've already calculated the rate, or effectively the velocity of the vehicle from the previous question, which is 0.16 meters per second. And once again, in that description here, the distance and the displacement that the vehicle traveled is effectively the same. So 0.16 meters per second. And then please be aware there's a parentheses around it, and I did that on purpose because it says velocity squared here. However, in terms of when you write it out, it's 0.16 meters per second. So I'm just putting parentheses around this whole thing because you need to make sure that since this whole thing represents velocity, everything in here needs to be squared. So not only the 0.16, but also the m and also the variable s. And when you do that, your kinetic energy value will be equal to 0.012 kilogram times meters squared over second squared.